Hello everyone. So today we'll be solving a question related to linear differential equation, the one that I talked about a few days ago. So I told you about the way we usually solve using this method, and today I'll be giving one example which will need us to change it into the standard form in the beginning and then solve it. So the question is 1 plus x square dy over dx plus 2xy is equal to 1 over 1 plus x square. So this is the question. So what I told was that we need to make the coefficient of dy over dx as 1. So for that we have to get rid of it. So how can we do it? We can divide both the sides with 1 plus x square, and that way what we will get is dy over dx. Wait, this arrow does not look very proper. Yes, now it's a little bit better. So dy over dx plus 2xy over 1 plus x square is equal to 1 over 1 plus x square. Wait a minute. Let me write this a little bit properly. Yes, so 1 plus x square whole square. So yes, we get this. So this is the standard form. We have y over here and the term of x in the right hand side, so that makes sense. So now let's go to find the integrating factor. So before that, let's just integrate p dx, and I hope you know what p is. P is everything except y in this term. So it is 2x 1 plus x square, so is equal to 2x over 1 plus x square dx is equal to, I hope you very easily know the integration of this, that is ln x square plus 1 plus of course the integrating constant. So how did I get that? So the derivative of the denominator, that is x square plus 1, is equal to the numerator, so that is 2x. So in that case we can simply write ln x square plus 1. That means ln and inside the denominator. And how did this come up? You can just suppose the denominator to be, let's say, p, and then differentiate p with respect to x. You would get dp over p, and then for that you can write ln p, and then we've supposed x square plus 1 to be p, so you will get this whatever I have selected over here. So this one, so now what we can do is integrating factor is equal to e to the power integration of p. So the integrating factor for this question is e to the power ln x square plus 1. And I think you know that if we have e to the power ln, whatever it is, then it just kind of nullifies the effect, and we simply get x square plus 1. So yeah, this is what we get. So I hope you know this. You can simply prove this using the property of logarithm and exponential number. So after this, let's go to the next page. Yep. So where are we? Yes, so we've got the integrating factor. Now we just have to multiply the standard form with the integrating factor. So this is the standard form. This equation that I'm labeling as 1, it does not look like 1, but then let's bear with it. So now what we have to do is multiply. So after multiplying, what we get is 1 plus x square. Let's keep a bigger bracket, dy over dx plus 2xy over 1 plus x square is equal to 1 over 1 plus x square whole square, yep, times 1 plus x square. wait a minute, I don't think the stylus is working very well. Anyways, so yes, this is what we have now. This entire thing gets cancelled by the power. So what we now have is, what we now can see is in the right hand side we have simply 1 over 1 plus x square. And I've talked about what we do with the left hand side, that is we apply the product rule, and this entire thing can be written as d oh wait a minute, yep, dy times 1 plus x square over dx, of course, is equal to 1 over 1 plus x square. Wait, let me change the color. Yep, so after that what we have is this. So now we can send the dx to the other side and then integrate both the sides. And I think you know that whenever integration and derivative come together, they nullify the effect, so it just gets cancelled out. I've talked about that in my previous video, which I highly recommend you to watch. I have briefly explained about linear differential equations, so that will make sense to you. So now what we have is dy times 1 plus x square is equal to integrating 1 over 1 plus x square dx, isn't it? Yes, it is. So now let's go to the next page. Please look at things. If you want to look, you can pause and even look. Now the final page. So what happens is, wait, so what I'm trying to see is this derivative, differential or antiderivative thing gets cancelled out, and what is left in the left hand side is simply y1 plus x square. And in the right hand side, I've done questions related to this in my previous videos as well. If you have 1 over x square plus a square, where a is a constant, then the formula that we use is tan inverse x over a. So in this question we have 1 as a, so anything divided by 1 is the number itself. So in the right hand side we will have tan inverse x over 1, which makes no difference, so you can simply write it as tan inverse x plus the integrating constant. So now if you just want to take everything to the left hand side, then you can write it as y1 plus x square minus tan inverse x minus c is equal to 0. So there you go. This is the final answer to this question. I don't think there is any difficulty in this question. Didn't require a lot of extra knowledge. Yes, the first one is you have to change the coefficient to 1 of dy over dx, and maybe this property of logarithm and exponential number that you have to understand. And I think the rest of it is very clear. Yes, and of course about the product rule in this page, in this step, and the rest is pretty easy. So yes, there you go. This is the final answer to this question, this one. I hope you learned how to do this, and hope to see you in my next videos. Thank you.